related issue. So in this session, we will be discussing about the supervised technique of discretization. So here also we will be dealing with the entropy based approach. So when I say supervised discretization, while performing a discretization, if we keep in mind about the class information, it leads to a better discretization to be performed. Such discretization is referred to as a supervised discretization or a supervised approach. In this case, the split points are kept such that the purity of the interval increases. So when I say purity of the interval, it means that data belonging only to that particular class label exists, or about 90% of the data present in that particular category will be belonging to a particular class label. So that is what is purity. Say consider if I have a class label as male and female, in the category where male is there, all the objects or 90% of the objects will be male only. So that is what is purity. So to the maximum extent, the data objects present must belong to one particular class. That is what is purity here. So for this, we are going to consider an entropy based approach for performing the supervised discretization. First, let us try to understand what is entropy and how it helps in the discretization process. So when I say entropy, entropy is the measure of randomness in the set. When I say set, it is nothing but the attribute values what I'm talking about here. It is measured from the range. The value of entropy lies between 0 to 1. So if a set has an entropy of 0, then it means that all the members of that set are very similar to each other, or say consider it belongs to a particular class. And if the value is not equal to 0, that is if it is equal to 1, straight away I can tell that it is an impure set. That means the maximum values does not belong to a particular class label. So now in order to find this, we have certain formulas and also certain variables that we need to understand. So let us see one by one. First, let us consider how we will be finding entropy for a particular interval, that is entropy for an ith interval. The formula here is ei. Here ei represents the entropy of the ith interval is equals to negative summation of j equal to 1 to k pij multiplied by log pij to base 2. So now we'll see in detail what here each term is. So when I say k here, this k indicates the number of different classes that we are having. Ei indicates entropy of the ith interval. This Pij indicates the probability of class J in the ith interval. So this Pij is calculated using the formula Mij divided by M, ratio of Mij divided by M. When I say Mij, it is nothing but the number of values of J in the interval I, and Mi is nothing but number of values in the interval. So about these, you will understand when we consider a particular problem and solve. For as of now, you consider this as the formula which helps us to find the entropy of a particular interval, that is ith interval. Now next formula what we have is to find the total entropy of the particular partition. So for this the formula is E is equals to summation I equal to 1 to k Wi into Ei. Here Wi is nothing but weight, so we call it as a weighted sum also. Clear? That is the weighted average of the individual interval. So here E indicates total entropy. Again, as previous, K gives the number of class present. Wi is nothing but the fraction of the value in the ith interval, and this Wi is calculated using the formula Mi divided by M, where Mi is number of values in the interval I and M is the total values. So using this formula, we will be able to calculate the total entropy. So once the total entropy and the entropy of a particular interval is calculated, the next thing that we are going to calculate is the information gain. And using this information gain value itself, we are going to measure the best possible category or the best possible split. So formula to find the information gain is G is equals to E minus EI. So where G indicates the gain and capital E is this, E is the total entropy and EI is entropy of the ith interval. So these are the formulas which helps us to identify a particular best split and categorize the values accordingly with respect to classification. This is very, very, very important formulas, students, as this the same formulas will be used in the classification modules also to find the best possible classification. Okay, so what we do here is, now let us consider an example and see how the example works and how we'll be able to solve the find the best split. Okay, so consider the sample data given here. So what he is given is he is given a set of values where each ordered pair here represent the attribute value and the class to which that particular value belongs. So here when I say 0 comma y, it means that 0 is the attribute value and y is the class to which it belongs. So from this data set given, I can make out that there are only two class labels, one is y and other one is no, sorry, n, which is nothing but yes or no. Okay, so what he is telling us is he is telling us find two intervals such that purity of the interval is maximum. So out of this for this particular data set given, I have to find a split such that the purity of that particular split will be high. So for this, what I do is first I consider them in the form of a tabular table so that it becomes easy for me to make the required analysis. So S is equals to the same data, this data, whatever is represented in the form of a set, is being transformed into a tabular form. So now I have to split this. So he's telling that find two intervals such that the purity of the interval is maximum. I have to find two interval. I have to split this entire data so that the purity is high. So let's say consider I have two split points. One split is at 14, so that is I'm going to split this data set at this particular junction, wherein I'm going to get this as one partition and this as the other partition. Say consider there is one more split which is at the point 21. So here if I split it here, then from 0 to 18 it becomes one data set, and this from 24 to 28 becomes the another data set. Now what we have to do is we have to calculate the information gain at when I split it at 14, and also I have to calculate the information gain when I split it at 21, and see whose information is greater, whether it is split information gain of at 14 is greater or information gain at 21 is greater. So to do this, so first let us consider the splitting at 14. So when I split this data set at 14, I'll be getting two partition. One is I consider it as S1 and the other one I consider it as S2. So now what we have to do is we have to calculate the entropies, entropy for the partitions and entropy for overall entropy, and then from that I'll be calculating the information gain. So first what we do is since this S will not change whether it is a split at 14 or split at 21, the values of S and the number of values given here will not change. First let us find the overall entropy of this. So I will find overall entropy of S, that is E of S is what I'm going to find, entropy of the original set. So original set is this, I'm going to find the entropy of this, that is EI. E of S, entropy of S is equals to negative summation of j equal to 1 to 2 Pij log Pij base 2. So here Pij is nothing but the probability of individual classes. Clear? So the how many classes are there? Two. Say why I have taken two here instead of k, I have taken two in this formula now, right? So why is this two? That is because I have two classes here. One is yes and the other one is no. So because of this reason, I have considered two. So now when I expand this, so first this is how I expand it. Now see this part here, this is for the class Y, and this part here what I've got is for class N, that is N. So now just listen to this, I'll be telling how I got this. When we saw the formula Pij, it is nothing but Mij divided by Mi, correct? Mij divided by Mi. So what was that Mij? It is nothing but the number of values which belongs to class J in the ith interval. This is the interval that I'm going to consider, correct? This is the interval, that is the entire interval. Number of values that belongs to S class. How many values are there for S class? 1, 2, 3, 4. correct? 4 S class values are there. So Mij is 4 divided by total number of values in ith interval. So what are the total number of values? How many values is there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 8, 9 values. So this is with respect to S class. That is for when j equal to 1. Now when j equal to 2, say consider, I'm going to consider it for no class. So now what I'll do, I'll measure Mij, that is j is equals to no here, number of values which belongs to n class. So calculate the number of values here, 1, 2, 3, 4, 5. So with respect to that, I'm going to get 5 here. So hope this is understood for you. How I have written, since the number of class given in that set is 2, k value becomes 2 here, which means that there are two classes. So this Pij will be first applied for the first class, and then again it will be applied for second class. When I say first class, it is S class here, and when I say second class, it is N class. Okay, so based on that, Mij I will calculate where Mij is nothing but number of values that belongs to jth class. Jth class, for j equal to 1 it is yes, and for j equal to 2 it is no. So now we'll make the simple mathematical calculation. So what I get is, for this, what the value, mathematical value that I get is this. So based on it, the final value is E of S is, the entropy of S is 0.991. So this is nothing but the simple calculation which you can do using your calculator. So now I have got the entropy of the overall set, which is equals to 0.991. Now what I do is I find entropies for each split. So how am I going to do that? So entropy of the partition, that is Es of 14 is nothing but weighted average of Ei. So expand this, what you will get? I'll be getting it like this. So when Wi is nothing but Mi by M. Correct? Mi is what? Number of values in the ith interval, and M is total number of values. So here Mi is nothing but I am having two intervals, S1 and S2. So here first, when j is equals to, when I is equals to 1, so sorry, it should be I here. You just change it to I. So this is I, this is not j, this is I. Okay. So when this is I, when I is equals to 1, it means when W1 into E1. E1 is nothing but here S1. E1 is nothing but S1. W1 is nothing but M1 by M. M1 by M. What is M1? It is nothing but cardinality. What is that cardinality? Total number of values in the ith interval. So first, if I want to get to know this, then I want to find the entropy of S1 and entropy of S2. So first I will find this and then substitute its value here. So if you want to find entropy of S1, that is for the particular partition, that is ith interval, this is the value. This is the table S1 value, S1 table what I am having. Formula is this. So now Pij is y, and n, there's no n class here, right? So it becomes 3 by 3 log 2 3 by 3. So you know how you will calculate this, right? So it is Mij, that is number of values which belongs to S class and total number of values in this interval. So there are three values. So in the denominator you will get 3 in both the case, that is in both these terms, and in the numerator, why I am getting 3 here? Because all three values belongs to S class. And here in the numerator I am having 0. Why it is? Because I don't have any values which belongs to N class. So finally when I calculated what I'm going to get, I'm going to get it to be as 0. So students, you can remember one thing here. Whenever you have a interval in which all the values is belonging to only one class and there is no other class value present, then entropy of such interval is 0. As in this case, I have values belonging to only S class and there is no class value, right? All these values belongs to one particular class. The other class value is not there, so directly I can write 0 without calculations also. So this will be a shortcut method for you in your exams. Now similarly, now I'll find for S2. For that, first I'll consider table. So here if I see, I have elements belonging to both these class, correct? So now when I, with respect to the formula, if I'm going to split this, How am I going to write? I'm going to write it as I is equals to 1 to 2 Pij log base 2 to log Pij to base 2, right? So now I'm going to expand it. So how did I get this? What is this 6 here? This 6 represent total number of values present. What is this one? Number of values belonging to S class. So how many S class values are there? Only one, correct? And what is this 5 here? This 5 indicates number of values belonging to no class. So it is 5. So similarly, when you calculate, this is for S class, this is for no class, and when calculate, you will get it as 0.65. So you are going to get it as 0.65. So now you have calculated entropy of S1, you have calculated entropy of S2. You know the number of values present in each partition, that is S1 and S2. So now you can easily find entropy for S of 14. So what is that entropy for split at 14? So the formula again it repeats. So S1 and S2 is this. You have already found the values also. So based on the values, we will be substituting entropy of S1 previously found as 0, entropy of S2 previously found as 0.65. What is this 3 and 1? S1 is nothing but number of values present here. Now, mod S is nothing but total number of values. So 3 by 9. And what is this S2? Number of values in S2, which is nothing but 6 by 9. So entropy of S, 14 is 0.433. So now I'll calculate information gain. What is information gain of for the split at 14? It is nothing but overall entropy minus entropy for split at 14. So overall entropy is 0.991 and entropy for split at 14 is 0.433. So when you subtract, you are going to get it as 0.577. So this is the information gain at for SCGS at the for the split at 14. So same way, similar approach you will take for finding entropy for the split at 21. So when I split it at 21, again I'm going to get two partitions. So this time instead of writing it as S1 and S2 and get confused with the previous thing, what I'm going to do here is I'm going to take it as S3 and S4. So now what I do is first overall entropy need not be found again because values of S will not change whether it is split at 14 or split at 21. Entropy of S remains the same. So I'll not calculate that directly. I'm going to calculate entropy for split at 21. So what will be the formula? The formula will be weighted average of E1. So according to that, here you will be considering the same thing again. Since we have taken it as S3 and S4, we will calculate the values accordingly. We'll be calculating the values accordingly. Clear? First, I'll find S3 entropy for S3. So this is the value or formula for us. So this formula now will get expanded. This is for S class and this is for the no class. This is the value that I'm going to calculate through the calculator, and then I'll get the values for S3 entropy of S3, which is equals to 0.9182. So just make a note of this. How did you get this 4? This 4 is nothing but number of values which belongs to S class. So how many values are there? 1, 2, 3, 4. And this 2 is nothing but number of values which belongs to no class, and this denominator is total number of values. Similarly for entropy at S4 you will do, so 3 values is there. So can you tell me directly what will be the value? 0, right? Why? Because you have the values belonging to only one class, whereas the other class value is not there, so it will be 0 directly. But anyways, we'll see the expansion also. It will be for y class it is 0, numerator is 0 and denominator is 3. For n class, numerator is 3 and denominator is 3. So this finally is equal to 0. So entropy of S4 is 0. Now we have calculated entropy of S3, entropy of S4. So now you calculate information gain for split at 21. So what is the formula? Information gain for split at 21. First entropy, this you find. Entropy for split at 21 we will find. So we have got it to be as 0.6121. This is again simple calculation. What is this S3? How did I get 6 here? Because S3 cardinality of S3. So it is nothing but number of values S3 has. And what is this 9? It is cardinality of, yes, what is cardinality of? Total number of values, that is adding these two together, S3 and S4 added together, how many are there? 9, right? So that becomes 9. This S3, entropy of S3 and entropy of S4, just now we found out, so no problem with respect to that. So you have got the entropy for split at 21. So once you have got this, you will calculate the information gain for the split at 21 using the same formula as before, which is equals to 0.3789. So now the two splits were given, 14 and 21. We have calculated the information gain for split at 14 also, and we have calculated information gain for split at 21 also. Now what I do is I compare these two information gains. So split at 14 is 0.575577, split at 21 is 0.3789, so which is greater? The split at 14 is greater. Therefore, from this observation, we can tell that the best split is the split at 14. That is, these are the partitions which will have maximum purity in it. So you can see that this is will this all the values here as yes, whereas maximum value here, that is 90% only, except one, all others are belonging to no class. So this is your discretization using supervised technique. So I recommend you to solve more and more problems, so you, which will be comfortable for the solving entropy, and the same technique is also used in classification, students. Therefore kindly revise this video once or twice and make a thorough understanding of what an entropy based approach is. Thank you.